ओके इस वीडियो में हम गेट 2025 का क्वेश्चन नंबर 62 डिस्कस करेंगे, जो क्वेश्चन लीनियर अलजेब्रा से पूछा गया था, एंड दैट वाज द लास्ट क्वेश्चन जो लीनियर अलजेब्रा से पूछा गया था. सो क्वेश्चन नंबर 62 क्या बोल रहा है? लेट x बिलोंग्स टू R3, कंसीडर द क्वाड्रेटिक फॉर्म. हमें एक क्वाड्रेटिक फॉर्म दिया हुआ है, एंड m be the symmetric matrix associated with this quadratic form qx with respect to standard basis of R3. Why is this? So हमें इसका लिमिट कैलकुलेट करना है. सो पहले हम एक बार क्वाड्रेटिक फॉर्म लिख लेते हैं. qx इक्वल टू 2x1 स्क्वायर प्लस 2x2 स्क्वायर प्लस 3x3 स्क्वायर प्लस 4x1 x2 plus 2x1 x3 plus 2x2 x3. So this is the quadratic form. So if we calculate the matrix M associated with this quadratic form, M क्या होगा? M एक 3x3 ऑर्डर का मैट्रिक्स होगा जिसके डायगोनल में आएगा 2 2 3. ठीक है ना? इस साइड में आएगा 2, इस साइड में भी आएगा 2, इसमें 1, इसमें 1, इसमें 1, दिस इज अगेन 1. So this is the matrix M. Now if we calculate, first what I'll do, I'll calculate the eigenvalues of M. So if you calculate the eigenvalues of M, I already have calculated that. Eigenvalues of M are, M का eigenvalue आएगा 5, 2 and 0. 0 eigenvalue आएगा. It is very much clear that first row, first column and second column is identical, and if you check the other two eigenvalues, that are 5 and 2. Okay, I am not wasting my time by calculating the eigenvalues. So अगर m का eigenvalue 5, 2 और 0 आएगा, so therefore eigenvalues of m plus I are 5 plus 1 6, 2 plus 1 3, and 0 plus 1 is 1. Now interesting point is just as m is a symmetric matrix and I is a symmetric matrix, if you calculate m plus I transpose, that gives you m transpose plus I transpose, which is again m plus I. So m plus I is also symmetric matrix. Now there is a very beautiful result about a real symmetric matrix, that a real symmetric matrix is always orthogonally diagonalizable. Real symmetric matrix is always orthogonally diagonalizable. Okay, a real symmetric matrix is always orthogonally diagonalizable. तो हमें क्या मिलेगा? We can consider an orthogonal basis v1, v2, v3 of R3, where each vi is an eigenvector, right? This is the definition of a matrix which is orthogonally diagonalizable. I am considering v1 the eigenvector with respect to the eigenvalue 5 is 6, v2 is the eigenvector with respect to the eigenvalue 3, and v3 is the eigenvector with respect to eigenvalue 1. So therefore हम क्या बोल सकते हैं? I can say m plus I of v1 equal to 6v1, m plus I of v2 is equal to 3v2, and m plus I of v3 is equal to 3v3. सही है? अब they are saying y is an any non-zero vector of R3. So any non-zero vector of R3 can be written as c1 v1 plus c2 v2 plus c3 v3. ठीक है ना? अब then let's calculate m plus I is whole to the power n of y. So m plus I is whole to the power n into c1 v1 प्लस C2V2 प्लस C3V3, ठीक है ना। तो हम इससे क्या बोल सकते हैं, C1 m plus I is whole to the power n of V1 plus C2 m plus I is whole to the power n of V2 plus C3 m plus I is whole to the power n of V3. So हम इससे बोल सकते हैं C1 that would be 6 to the power n of V1 plus C2 3 to the power n of V2 plus C3 V3 V3, सही है ना। So now if we calculate y transpose m plus I is whole to the power n of y, so वो क्या आएगा, C1 V1 plus C2 V2 plus C3 V3 is whole transpose of 6 to the power n C1 V1 plus 3 to the power n C2 V2 plus C3 V3. Now हमें पता है ट्रांसपोज ट्रांसपोज को हम लिख सकते हैं C1 V1 ट्रांसपोज प्लस C2 V2 ट्रांसपोज प्लस C3 V3 ट्रांसपोज of 6 to the power n C1 V1 plus 3 to the power n C2 V2 plus C3 V3. अब क्योंकि V1 V2 V3 एक ऑर्थोनॉर्मल बेसिस है, हम बोल सकते हैं V1 ट्रांसपोज V1 दैट इज 1 एंड V1 ट्रांसपोज बोल सकते VI ट्रांसपोज VJ दैट इज 1 if I equal to J and 0 if I not equal to J, ठीक है ना। सो इफ वी मल्टीप्लाई दिस, पहले हम जब इसको इससे मल्टीप्लाई करेंगे हमें क्या मिलेगा, 6 to the power n C1 स्क्वायर, इससे इससे मल्टीप्लाई करेंगे तो 0, इससे इससे मल्टीप्लाई करेंगे तो 0, फिर आएगा 3 to the power n C2 square then C3 square. Now if I take 6 to the power n common, so I would have C1 square plus C2 square 3 by 6 is whole to the power n plus C3 square over 6 to the power n, right? So this is the value of y transpose m plus I is whole to the power n of n y. Now there an is given by y transpose m plus I is whole to the power n plus 1 y over y transpose m plus I is whole to the power n y. So I have 6 to the power n plus 1 C1 square plus C2 3 by 6 is whole to the power n plus 1 plus C3 square by 6 to the power n divided by n plus 1, sorry, 6 to the power n C1 square plus C2 square 3 by 6 is whole to the power n plus C3 square by 6 to the power n. So if I take, now I can cancel this, I would have 6. Now if I take the limit, so if I take the limit, so that becomes 6, this remains C1 square, this is 0 and this is 0 by this is C1 square I have, this is 0, this is 0, so cancelling C1 square into C1 square, this limit is 6. So as n tends to infinity, so limit an is 6, which is our required answer. So answer is 6. So that's all about our question number 62. Thank you.